that there's going to be huge impacts on the coasts.
In 2001, a rise of 3 feet was predicted, but a new discovery suggests future rises could be as high as 20 feet. The clues to this new threat come from a tiny organism that lived hundreds of millions of years ago, a creature that still lives in many parts of the planet today. Coral. Ancient coral reefs reveal how high sea levels can rise after a meltdown. This kind of tropical coral only grows in shallow water, just beneath the sea surface. If it is left out of water, it dies. If it is too deep in water, it also dies. It's an excellent marker of sea level throughout history. If coral beds are found high above present sea levels, this means that at one time, the water level must have been higher. Dr. Jonathan Overpeck and his team at the University of Arizona have been studying ancient fossil coral reefs from 130,000 years ago. By measuring the elevation on the coral, he can determine how high the sea level reached.
You needed to have a sea level rise somewhere between 13 and 20 feet, perhaps a little more, higher than today.
These ancient corals show that the water level was up to 20 feet higher than today. By studying ancient ice core data, Overpeck calculates the average temperature of the Earth at the time when the corals were alive. He's surprised by the results. The Arctic summer temperatures causing those high sea levels 130,000 years ago were a mere 5 to 8 degrees warmer than today.
We figured, by the end of this century, that's when we'll cross this point by which will be warmer than it was then, and therefore we'll get all this ice sheet melting. But lately, the Arctic has been warming faster than we expected, and now it's possible we could get that warm by the middle of this century.
By comparing melt rates from today, Overpeck concluded that the western Antarctic ice sheet may have melted as well as Greenland. And the mechanism that caused this massive meltdown is exactly the same that Eric Rignon discovered happening in the Larsen B ice sheet in western Antarctica. Just like in Larsen B in 2003, the warm water of 130,000 years ago was melting the substructure of the glaciers and ice sheets.
What was happening apparently is that the ocean was warming, and that was melting underneath the ice shelves. And then as these ice shelves disintegrated, that allowed the ice sheet to flow out to the ocean. That was a big surprise for us.
It seems history is repeating itself. The mechanisms that led to meltdown back then are causing sea levels to rise again today. Scientists are worried. Earth could be heading toward a total meltdown far sooner than anyone thought.
A lot of us, myself included, are really quite concerned that we might be warming the Earth past a point where these big ice shelves and ice sheets could disintegrate, raising sea level in dramatic ways. We could cross that threshold before we have a chance to even understand the process, let alone stop it.
The Earth is approaching a tipping point, a point where climate change gets so severe that it could spiral out of control. A temperature increase of just a few degrees would have an enormous impact on human societies and ecosystems. That will cause the warming to accelerate to a point where the Earth cannot recover. If Overpeck is right, we are on the brink of planetary meltdown. Unless we take urgent measures to reduce greenhouse gases, we could be looking at up to 20 feet of sea level rise. Overpeck has created computer simulations that show the effects.
This image is focused on the New York metropolitan area, so right in the center is New York City. We can see as we move to 1 meter or 3 feet along the southern margin of Long Island, you can see Fire Island would start to flood out at this, and up along Connecticut and the Meadowlands in New Jersey.
A rise of 6 feet results in further flooding of the metropolitan area of New York. As the waters reach 10 feet, large areas of New York City would be underwater.
Here is going up to 13 or 14 feet, and you can see here a lot of red and a lot of pink, and the pink is where we've flooded areas that are heavily populated.
But New York at least has the advantage of some high ground. Florida has no such luck.
Most of the big populated areas of Florida are along the coast, and surprise, surprise, they're impacted by sea level rise. I'll just ratchet us up to 20 feet, and you can see that the amount of area flooded in Florida could be just devastating.
It's a bleak vision of the future. Sea level rise out of control. 2/3 of the world's population lives within 60 miles of the sea. The effects of the coming meltdown could be catastrophic.
Temperatures might be climbing slowly at the moment and sea levels might be climbing slowly, but things are happening on the planet which are going to accelerate those things so that we see a very rapid change. The whole system is going to tip. We're going to see catastrophically rising sea levels, dramatically rising temperatures.
The problem is that as temperatures continue to rise, weather patterns begin to change. The Earth has many processes that keep violent climate change in check. Even ice itself is part of the process that keeps the Earth cool. But some scientists worry that these fail-safes are breaking down, and planetary warming is out of control. The Earth is heating up, the ice caps are melting, and sea levels are rising. Human industry is the cause, and that should mean we can stop it. But recently, scientists have discovered a new problem. Global warming is damaging one of the processes the Earth uses to regulate its temperature. Ice reflects the sun's energy back into space, and that helps keep the Earth cool. Melt the ice, and there is less ice to reflect the sun. More heat is absorbed into the oceans, and the cooling effect gets smaller. As more and more ice melts, more and more heat from the sun gets through, melting more ice. It's a vicious circle. CI's geophysicist, Professor Don Perovich, is on a mission to understand how the interaction between sunlight and ice controls the planet's temperature.
When it's all said and done, what keeps the Earth warm is sunlight. And how much of that sunlight is reflected is a key parameter in the global climate system. Now let's do a little experiment. I've got these two boards which are identical, well, almost identical, except for one thing. And you can see what the difference is. This board is black, this board is white. The white board, the snow-covered sea ice, is the best naturally occurring reflector on Earth. The black board represents the open ocean, which absorbs most of the sunlight. So let's just do a little experiment now. We'll measure the temperature of these two. I've got this nice little thermometer. I point it at it, and I can see that the temperature is 26 degrees centigrade, a little around 78 degrees Fahrenheit. Look at the blackboard, it's the same temperature because I just exposed them to sunlight. So what we're going to do is just take a couple minutes to see how the temperature changes between these two boards. Okay, let's take another temperature measurement. We'll look first at the whiteboard. The whiteboard, it's still at 27 degrees centigrade. Now let's look at the blackboard. The blackboard, it's increased to 48 degrees centigrade, almost 120 degrees Fahrenheit. Now this is a nice little experiment to do on a sunny day, but it also has ramifications for the Arctic sea ice cover. Because what we're doing as the ice cover retreats, as it's been doing for the past few decades, is we're replacing the snow-covered sea ice, the best reflector, with the open ocean, the worst reflector. And as a consequence, we've been putting a lot more heat into the Arctic system.
The measure of the reflectivity of a surface is known as its albedo. White ice has an albedo of 80%. Dark sea is around 20%. A snowball Earth would reflect 80% of solar energy back into space. An Earth with no ice would absorb most of it. And somewhere in between, there is